5 minus by 0.2 divided by 2. Okay. So to write this down, this is your width. This is your depth. This is your y bar. Okay. So you got your width, depth, and y bar. So this will be equal to 1.4 multiplied by 0.2 multiplied by another 1.4. So 1.4 times 0.2 times 1.4 is equal to 0.392 inches cubed. Now the shear that we are looking for, if this is our y, this is our z, and this is our rotation about x, and how the shear stress is flowing, okay, by looking at the Q. So we know that this is terminal and this is our Q. The direction of the shear stress becomes shear, the intersecting plane is x. Okay, so that plane is our x plane. However, the shear stress is in the z direction at point A, sorry, point B. So this will be equal to Vy over Izz. Qz, we know it's equal to 0.392. Thickness is this thickness over here, and divide by thickness 0.2. And then we have to finish off with a 2 down here. We have to finish off a 2 down here because this is a what? Box beam. In a box beam, you have what? 2Q. One goes to the left and one goes to the right. Concept is still the same. The shear force is still constant. The I is still constant. Are we clear? You don't start dividing, okay, Eugene, left to right, let's divide by, no. The 2 you include down here is because you are dealing with a box beam analysis. Okay. So this is equal to 0.392 divided by 0.2 divided by 2 is equal to 0.98. Okay, so you have Vy over Izz, and this is equal to 0.98. So from here, we know that the Q for point B, not theta, sorry. The Q at point B divided by T is equal to 0.98. Now again, we are dealing with what you see down here. We are dealing again with the Q over T ratio. Now, some of you will ask me, Eugene, why not we find the second moment of area first? Okay. So the question says that the maximum shearing stress is what? 10 KSI. So given to us that tau max is equal to 10 times 10 to the power 3 PSI, right? We need to locate where tau max will what? Will occur, right? So if now, again, this is a question that we did before. Remember the questions that we have this structure, yes or no? Right, remember that question? We are dealing with what? The Q over T ratio again, okay? So we realize that at point A and at point B, right, the thing equal to 0.2 inches. Can you see that? And then if I were to draw another line, which is at the centroid, and I'll call this point point C, and we realize that at point C, right, if we look at point C, the thickness now increased to what? Increased to 0.3. Okay. So we first have to locate where tau max is. Okay. We have found B. Next, we are going to find A. Okay. So now we are going to deal with point A now. So to deal with point A, I'm going to use this diagram down here. So at point A, right, we realize that what we are dealing with is it is a white flange analysis. And then we are only dealing with Q. Box beam is 2Q. White flange is Q because terminal 3 has nothing to do with terminal 2. They are independent. Okay, one Q go one side, one Q go the other side. Okay, and the Q that's flowing down, going down to terminal 3. So the area to consider is exactly the shaded area that we are dealing with. Okay, is exactly the shaded area that we are dealing with. Okay, so when that's the case, we want to find QZ at point A now with that Y bar. So we found the width to be equal to 0.7, the depth 0.2, the Y bar is 1.5 minus 0.2 divided by 2. So this is equal to 0.7 multiplied by 0.2 times by 1.4. So we have 0.7 times 0.2 times 1.4, 0.196 inches to the cube. Okay. So from here, we are going to find the shear Z plane. The shear stress is going X direction at point A is equal to Vy over Izz. Qz is equal to 0.196 divided by the thickness, which is equal to 0.2. And down here you put 1 because it represents Q, which is equal to the what? White flange. So 0.196 divided by 0.2 times 1 is equal to Vy over Izz, and this is equal to 0.98. So from here, we realize this number seems familiar, yes or no, right? Because if we go further up, earlier, at point B, you got 0.98 over Izz, right, Vy. And down here, we have the same thing. So the shear stress at point A and point B happen to be the what? Happen to be the same, right? So the next thing that we're going to do, there's only one more point that we don't know, and that is at point C, right? Shown down here. We are going to deal with point C. Okay, so we're going to find point C. I'm going to do point C both ways because I want you to be comfortable like me. Okay, whether we do it from the top or from the bottom, the answer should be the same. However, the analysis is going to be what? Different. Okay, as you know now. Okay, so now I'm going to take the same diagram from here. Okay. I got something that's bothering me down. So now we are going to find at this point, and this point is our point C. I'm going to do two methods of doing it. So we are going to use at point C is going to be a box beam analysis. And with this, we know that we are going to have 2Q. Okay. So QZ at point C, right? So we have to include this entire area also. I'm shading in green and the shading in black. So the whole area, right? So the first one, the width is equal to 2 minus 0.3, so 1.4, right? Multiplied by a thickness, multiplied by 1.5, minus by 0.2, divided by 2. So this is the flange region. Okay, so I'm going to label this region from here to here. This is our flange region. Then we have to consider the web plus by 2. 2 down here represent left and right. The width is 0.3. The depth is 1.5 multiplied by 1.5 divided by 2. So this will be equal to answer by 1.4. So we get 0.392 plus 0.675. So this is equal to 1.067. And then we substitute in now the shear intersecting the x plane. However, the direction is in the y direction, right? Because if you look at Q down here, Q is flowing vertically down, which corresponds to the y direction. Over here, Q is in the horizontal direction, so it's in the z direction. Okay. So at point C now, we will have By over Izz multiplied by 1.067. Now the thickness is at 0.3 and twice because it's what? Box beam. So 1.067 divided by 0.3 divided by 2 is 1.778. So Vy over Izz is 1.778 Vy over Izz. Okay. 1.778. Now, if you want to do from the bottom, the answer will be and has to be the same. Okay. Only thing when you do to the bottom is no more box beam, is a what? A white flange. Okay. So now we're going to deal with the bottom now. Okay, two ways of doing this. Okay. Why I do two ways? I want you to have confidence in the analysis. So now again, we are going to determine point C over here. So when that's the case, we have to deal with this area also. Okay. So point C Now we are going to use white flange analysis. And it's good practice to write down that this is Q.